Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at sequences, in particular sequences that are defined with a recursive formula. So let's go ahead and get started. Now, when we use the word recursive, that essentially means to repeat, or repetition if you will. That's essentially what it means. And so with the recursive formula in relation to sequences, what's happening is this. You are using the previous terms in the sequence to define the current, or you could say the next term. And again, I know that sounds very, very abstract and mysterious, but what I want to do now is I want to start with the old way, the explicit formula, show you how that one works again, and then show you how the recursive formula is different. So imagine that we have the following sequence. Here's the formula for it, if you will. We got a sub n equals minus 3n plus 8. Okay, so this is not too hard. So if when a sub 1, you're going to have minus 3 times 1 plus 8. Not that deep. And so you're going to get 5. I think we can all agree on that. And then if we do a sub 2, you're going to have minus 3 times 2 plus 8. That's going to equal, let's see here, 6. Negative 6 plus 8, that's going to equal 2. And you're getting the idea. We'll do one more. A sub 3, you're going to have negative 3 times 3 plus 8. It's going to equal negative 1. So you can see here, this is an explicit formula because the first term has nothing to do with the second term. And the second term has nothing to do with the third term. They're completely independent of each other. A sub 1 does not affect A sub 2. A sub 2 does not affect A sub 3, etc. They're all independent. However, when you're dealing with, and just draw a line right here because I want you to see the difference. When you're dealing with the recursive formula, it gets much more tricky because you must define at least one initial term. That is the term you start with because you use that one to build the output for the second time through the sequence, and then you use the second time of the sequence to build the output for the third output. That's how it works. And so let me see if I can try to simplify this for you. So we're going to have, use a slightly different color here. A sub 1 is going to equal 2 in our situation, and here's going to be our actual formula. We're going to have a sub n equals 2a, and then underneath it we're going to have n minus 1 plus 1 like this, and then this is for all cases where n is going to be greater or equal to 2. Now here's what's happening. Let me see if I can make this nice and simple for you and try to explain this as clearly as possible. So here's what's happening. Our first term is going to be a sub 1. That has already been defined for us as 2. In other words, there's no calculating the initial term. It's just given to you. That's one of the unique characteristics of a recursive formula, a recursive sequence, if you will. Now, let's see what happens for n2. All right. So n sub 2, n sub 2 is going to equal the following. It's going to equal, it's going to equal 2a, and so this is going to be our second term minus 1 plus 1. That's what we're going to get here. And so if we work that out, this is what we're going to end up having. We're going to have 2 times 2, because when you do 2 minus 1 here, you're going to get the first term. So we're going to be 2a, but the a is going to be a1. Do you understand? So what's happening here is that I'm starting with a sub 2, but I'm subtracting 1 from that n there. And so when I subtract a sub 2, I get a sub 1, which is right here. And so I plug in, what is a sub 1 is 2. So 2 times 2 plus 1 is going to equal 5. And I repeat the process. So when I do a sub 3, this is what I do. I do 2, and now I plug in the results for a sub 2, because I'm going to do 3 minus 1, which means I'm going to take the second output, the second term, if you will. So I'm going to put in here 5 plus 1 equals 11, and I'm sure you're starting to get the idea. And so A sub 4, you repeat the process. This time I plug in the results from step 3, A sub 3. So I put in 11 plus 1, I'm going to get 23. And so you can see one of the major differences is this. When you're doing the recursive formula, which is all this information on the right, you are using the output from the previous term to calculate the current term. And then you repeat this process. So to give you some visualization of this, this is kind of what I did. You have an initial term. You don't calculate this. You give it to it. So there's an initial term that you have to already have previously defined. You take that and you plug it in for the second time through, which is what I did right here. So I took that 2 and I plugged it in. I got the 5. And then for the third time through, I take the 5 and I plug it in. And then for the fourth time through, I take the 11 and I plug it in. The output for the previous, loop to the sequence is used to calculate the current one. And that is what makes a sequence a recursive formula. So I pretty much summarized what I did today, but just to kind of wrap things up, a recursive sequence is when you use the previous terms to define the next term. And so I explained it to you. This is different from the explicit formula where the terms do not have an influence on each other. You just go up sequentially 1, 2, 3, 4, 5, and the outputs are independent. But with the recursive formula, the output is dependent on the previous inputs, and that's a major difference between the two. And so there are times when this is a very practical approach to doing something like Fibonacci sequences and a lot of things that are found in nature or whatever. We'll talk about that more in the future, but that is just an introduction to how this particular approach to sequences works. So I hope that this video was useful for you and that you were able to understand what we talked about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.